Okay, so here's my main compressor, and I just wanted to show this as an example of how the uh, storage process of the gases would start. Instead of having these are just air filters right here that where the air intake is for the pump. These are just little plastic containers that hold the filters. But just like in the back here, these are the hoses that fill the tank right here, and they get quite warm because of the pressure. But that's why they have this radiator grill stuff around it. But instead of having these filters in the front here, there would be hoses like that would be connected to the shafts of the that go down to the reservoir, and that's what would be connected to these two intake uh, parts of the air pump right here. And I guess we would probably have to have some sort of a pressure reading for the shaft itself. That way you know that you can start the pump. So this tank is a 30-gallon tank, and it only is designed to go to like 125 psi. But in the storage facility, the tank that you would want would be a bigger capacity version of the high pressure air cub tank, and I'll show that in a moment after this one's filled. Alright, so I got the air cub tank out here, and the compressor is still filling inside, but I was just looking over this writing on the side here, and it says that it's only a 15-minute self-contained compressed air breathing apparatus, and it just seems like with this kind of pressure capability you would have more than just 15 minutes of breathing time. But it does state right on here that this tank could hold oxygen, or just so this is a actual tank that would be able to hold the oxygen gas. But as far as the hydrogen gas goes, I'm not sure if it would be exactly the same as this, but they wouldn't be at pressures such as the fire extinguisher tank. I guess those pressures are too low. So this is it's going to be kind of my example of how you could fill up or how you hook up these tanks from the main tank. Like the main tank inside would be collecting gases throughout the daylight hours, and when it's over with, when the daytime's over with, then you would unhook from the well shafts, like with a hose like this, and then connect it to, the pipe or the tank that you want to put the hydrogen or the oxygen into. In this case, it'll be oxygen. So then the gauge is probably barely. I bet this gauge is probably barely going to go up, but it's starting to fill. It's starting to take compressed air from the main tank and putting it into this tank. Well, I guess it moved a little bit. I thought it would move a little bit more than that for 100 pounds of pressure. But anyway, so the main tank in there is only 125 psi. I mean, I wish I could go as high as this tank could accept. That'd be really cool to have that kind of high pressure capability, because that's a lot of energy behind that kind of pressure. So, all right, so then we just unhook it. So now there should be some compressed air in there. So just like that, you would pump with the main tank like I showed on the inside. Then once the daylight hours are over and the electrolysis can't be done anymore, then you would discharge all the captured gas into individual storage tanks like this. This would be an oxygen one, and the hydrogen would have its own. And then once they're all separated into their own tanks, And out of the collector tanks, then you would take each of those tanks and hook it up to a single tank with water in it, just like this one, and recombine both gases into the same tank. But to make sure you got a good mixture, once this tank is full, or got as much as the two gases in there as you can, then you would simply just slosh the water back and forth like so on the inside, and that would safely mix the two very explosive, very flammable gases in a safe manner, because I'm pretty sure that the water would not affect the hydrogen and the oxygen in the tank, because there's no way that you can get a spark to ignite the potential gases energy that you have in there with water. That's one of the main beautiful things about water here is it's going to be used to mix. You're going to be using it to gather the gases, and then once they're mixed like this with water, then you can discharge it and then ignite the discharged gases, here in some way. You can also have the valve kind of control how much pressure you're getting too, it seems like. So all very controlled, a very controlled method, and the technology already exists, and it's existed for a long time to do this. But I don't know of any power station that has ever done electrolysis in a water reservoir underground and captured them, put them into a single tank after individually capturing the gases. Because I think the main trick was to be able to mix them back together safely, because I've been looking online, and the only demonstrations I could find on recombining oxygen and hydrogen is people are using balloons or little ways of pocketing the gases in a cup that's upside down or something, and then just lighting a flame to them, which is very crude and unsafe if you ask me. But I don't think there's anything unsafe about mixing the two gases together and using water inside a pressurized tank to do that, because the only thing that would make it unsafe is if there was an electric fan or something like that trying to mix the gases together without the water in the tank to slosh around, because that would, there could be a possible spark hazard there. But there's no possibility of a spark happening with just the water sloshing mixture. Anyway, hopefully someday somebody will make this power station.